Hello and welcome to another edition of Cracking the Cryptic, where we're going to crack the deadly killer Sudoku today on the 22nd of December from the Times. So those who've been following this series will know the form. So start off, I'll just put in the obvious boxes that can be limited to a relatively small number of numbers like this. I think something to note immediately: once you have a 1, 2 in a box like this, and you also have an 8 in two cells, that forces the 8 to be 3, 5. And you should be able to fill in this cell immediately just by using the rule of 45. So we know this 3 by 3 box will contain the numbers 1 to 9 exactly once each, and the numbers 1 to 9 sum to 45. So 3 plus 8 is 11, plus 25 is 36. So this is a 9 in order to make sure that the box works. Now let's just have a quick look there, because that is quite interesting. Can't quite force. I was wondering whether this 16 could contain a 9. I think it can, even with the 8 in the box. So we can't quite force this number to be a 9, but I think it's quite likely it will be, but we won't assume it. Okay, so where can we look next? Okay, I'm looking at the top 2 rows here, and I'm seeing we can isolate the value of these two cells, and therefore these 2 cells. Now it's likely that if we do that, one of those things will be useful, so let's do it. So we've got 33, 68, 82. So these 2 add to 8 and these 2 add to 10, so unfortunately not that helpful, but we need to try and remember that for later, because that will be useful at some point during the solve. Just notice we've got this 9 here. We'll look at the 22 box up here. 22 must contain a 9. It's either going to be 6, 7, 9 or 5, 8, 9. Well, the 9 can't go in either of these 2 positions, so it must go here. So let's put that in. Quite an interesting couple of shapes in here. Look at this shape. 39 in 7 cells. Now, something we need to remember, therefore, is that the 2 cells that are missing from this 39 box will sum to 6. So they'll either be 2, 4 or 1, 5. So we certainly need to try and use that fact as we're going through. And there are a variety of ways, I think, of trying to make some progress here. So we can see this is a pretty extraordinary selection of numbers here going into this bottom left-hand box. So we know this box adds to 45, and yet we've got, what's this add up to, 68, 76 in these 3 boxes. Well, that means that these 4 squares here must add to 31 in order to ensure that this box, this total 3 by 3 box, adds to 45. Well, if these 4 boxes add to 31, this can't be a 5. Because this is a 5, these 3 cells will have to add to 26, which is obviously impossible. The most 3 cells can add to in the same 3 by 3 box is 24, 7, 8 and 9. So this is not a 5. And I suspect if we work hard on that, we could actually take that further. But I'm just wondering whether there might be a simpler way of making progress by looking at these 2 cells. We can isolate the value of these 2 cells. I'd encourage you to pause if you can't see why. But the way we can isolate the value of these 2 cells is to imagine a line coming down the grid like this. Now we know that if we add all of the numbers that are going to appear in the completed solution to this puzzle to the right of this line, they will sum to 180, because we've got 4 complete columns of 1 to 9, so 4 times 45 is 180. But we can also see that to the right of this line we've got a number of complete boxes, and if we add all of these complete boxes together, we will isolate the value of this, because this will be the difference between 180 and the value of all these boxes being summed together. So let's just quickly add this up. So we've got 33, 73, 89, 96, 120, 128, 136, 139, 164. So these two boxes add to 16, which can only be done if these are 7, 9, 7, 9 like this, and we've got a 9 here. So that is helpful. We can fill in that 9 and that 7 like that. In fact, that's got to be 9 in one of those two positions there as well. Now, can we go further? 16. So these are now adding to 19. Yeah, this is also interesting. Well, if we look at these 5 cells, sorry, we know these 5 cells are summing to 26. And we have a 9 here, so that's 35. So we know this cell, and this cell have to sum to 10. Now there are only a relatively small number of possibilities therefore for this cell here. It can't be a 7, and we now know it can't be an 8 either, because otherwise both of these cells would have to be 1. So this is either a 5 or a 6, which means that one of these, well, it means 1, 2, 3, 1, 2, 3 are the possibilities for those two cells there. And this can only be a 7 or an 8. And then I'll show you something quite cool about this puzzle. I said we might be able to work harder down here and make some progress. Well, I think that we can. So you remember on 39 I said it either doesn't contain a 1, 5 or a 2, 4, because we know we need to leave 6 and 2 cells out of this 39 box. Well, let's just ask ourselves the question, where does a 4 go in this bottom left-hand box here? Well, a 4 can't go in this 8, obviously, because then there would be 2 4s. So therefore there is a 4 in one of these 4 cells. Now, as there is a 4 in one of these 4 cells, there is not a 1 or a 5 anywhere in this 39 box. Now, that being the case, I need to place a 1 in this bottom left-hand box. Where can I do that? Well, I can't place it here, I can't place it here. Therefore, this 8 is a 1, 7, which is perhaps surprising, but is true. That means that this is a 7. And we can eliminate 7 from here like this. And the most obvious implication of this is for this 9 here. We now know that this 16 box does indeed need to contain a 9, and if it needs to contain a 9, it also needs to contain a 1, 2 and a 4, because that's the only way we're going to get to 16 in 4 cells containing a 9. So in fact now we know this is 1, 2, 4, 2, 4, 9, 1, 2, 4, 9. This can't be 1 or 2, so this has to be 4 or 9, like that. Now that means that this 8 cannot be a 1, 7 or a 2, 6 anymore. It has to be a 3, 5. There's the only option left for that, which means these two cells here are 6 and 8. Now this cell cannot be an 8, because this would mean these two cells have to be a 1. So this is a 6, and this is an 8, and this is 1, 3, and this is 1, 3. And all of that, you know, which is quite a considerable move forward in the solving of the puzzle, is simply deduced from asking ourselves where a 4 goes in this bottom left-hand box. And I think that's, you know, I think that's really quite a smart piece of setting, whoever did this. That's very, very nice indeed. Now, simple Sudoku logic now tells us this is a 7. And okay, so these two are 14, which means they'll either be 5, 9 or 6, 8, but I don't think we can quite tell which yet. Interestingly, we can isolate that there is an 8 and a 9 in this column, but still we can't quite tell. We know they're both not in here, so this is an 8 or a 9, but we don't know which one of those two it is. I'll make a little bit more progress by using this 7. It's going to force a 7 into one of these 3 cells, which means that the 7 in this 3 by 3 box has to be in the top row. So that allows us to put this in like this, which isolates the value of the 1 here. Which, again, simple Sudoku logic now enables us to place a 1 here. And that's quite interesting. Now this box is getting very congested, so we've got 18 here, plus 17 is 35, so these two cells have to sum to 10. Now I think we did some work earlier, didn't we, and we concluded that these two cells also had to sum to 10, because I think we worked out these two cells have to sum to 8. So we know now that this is either 4, 6 or 2, 8, and this is either 4, 6 or 2, 8, which means that these two cells have to be 3, 5. And look, we've got a 3 here, so in fact this is a 3 and this is a 5. And now that's nice, because this 5 here checks this 5 here. 5, 5, that means there's a 5 in one of these two positions, which means that the 9 is indeed in the 21 box, and this is an 8. Like that. There's a 6 up here in one of these two positions. This can't be a 9. Okay. Do a bit more simple Sudoku logic here. 2, 4, 2, 4. So we're looking at 3, 6, 3, 6 down here. Oh, no, I definitely don't want it to be 3. I want it not to be a 3. Don't let me delete that. There we go. And as we know, these add to 10 and these add to 16. That's 26. So we know these two cells here add to 9. Now, unfortunately, now there's too many possibilities still there, so we can't eliminate down. Probably the easiest option is to just start noting in some of the things we've forced. You can see this 24 box here. These two cells have to add to 7. So 1, 5 and 3 are the options there, but again we can't quite eliminate down. It's interesting to note we've got two boxes of 2 containing in effect 7 in this same row, and this is a 1 and a 3. So there you go. That is interesting, I think. Let me explain what I'm thinking. So these two add to 7, these two add to 7, and this cell here is a 1 or a 3. That means we've got 5 cells here that sum to either 15 or 17. Now, can we use that fact? Not quite. If we knew this was a 1, then obviously these could be filled in. They would have to be 2, 5, 3, 4, because the 5 boxes would add to 15. But I don't think we can quite make that deduction yet. Let's go back and have a look at this 39 now. So 39, we've already got 9 and 6 in, so that's 15. So these 3 cells have to add to 24. And there's an 8 here, so that's helpful. Okay, so this is 7, 9. This is 7, 9. there's a bit of arithmetic that we can do now to isolate some values. So this is 24. Now if we look at these three cells must sum to 13 because of this 8 here. So we've got 13 plus 24 is 37. These three cells have to sum to 8, which means there's definitely a 1 in here, but we can't quite tell where. But as these add to 8, these three cells have to sum to 22. So again, there's definitely a 9 in here, which we could see from before. This is either going to be 6, 7, 9, or it's going to be 5, 8, 9. Trying to remember what we concluded these two added up to. Right, 22, 36. These were 9, weren't they? So we have a 7 already. And we can again actually use Sudoku logic now to take us forward. So we worked out these three cells added to 22. But look, there's a 3 here. And this cell cannot be a 3 because of this 3 down here. Now that means the only place a 3 can go in the top left 3x3 box is in one of these two cells. Now that, in turn, we know these two added to 9, so this must be 3, 6, which forces us the 6 down here to be like this, which means this is a 2 and this is an 8. And what's more, we now know that this must be 5, 8, 9 because there's already a 6 in the box. So 5, 9, 5, 8, 9, 5, 8, 9, like that. Oh, that doesn't look good. Oh yeah, and that's because when we worked out that these three cells had to add 10, I put 1, 2, 3 as the possibilities. Of course, it should have been 1, 2, 3, 4 as the possibilities for these extreme cells here. But nothing's turned on that. We haven't used the fact that this could be a 4 in any way that restricts us. So we get there, and we get there, which is okay. Forces an 8 here, which is nice. This can't be a 5. This can't be a 5. This can't be a 2. Oh, and look, we've now got a 1 and a 3 here, which is nice. Okay, so this has to be 2, 5. Which means this has to be a 2 by Sudoku logic, because we have a 2 in one of these two positions and a 2 in one of these two positions. So there cannot be a 2 anywhere else in these two columns, and there cannot be a 2 anywhere in these 6 cells either, because these 2's are preventing it. So there must be a 2 here. Okay. So now we're looking for 3, 7 to place in one of these two cells. So 3, 7, 3, 7, which means that if this was a 7, we'd have to place a 4 in here. If this was a 3, we'd have to place an 8 in here, like this. Now I wonder if one of those is impossible. Clearly that's impossible. The others still look just about okay, don't they? Which is a bit irritating, but I don't think we can force the issue there. See, this is going to be 1, 4, 6 in some order. And I guess the next thing I'd use is the fact that we've got this as 5, 8, 9 now, and that's interesting for these 3 cells, because we worked out these 3 cells added to 8. Now 8 in 3 cells can be done in 2 ways. It can be done as 1, 2, 5 or 1, 3, 4. Well, we know one of those is now illegal because of the rules of the puzzle. This now has to be 1, 2, 4. Sorry, 1, 3, 4. Because there's already a 5 in the box. So let's put that in and see if it helps further. Well, it does a little bit, because we can now see that there is a 4 in one of these 3 cells and a 4 in one of these 2 cells. That means there cannot possibly be a 4 here as well, because otherwise, you know, these boxes are not fillable. So this has to be a 1, and this has to be the 4, which enables us to finish off this box now with 2, 4 and 7. Well, we know this can't be a 4, and we know this can't be a 4. So in fact, this is a 4. And can we use the 2, 7 anyhow? I feel like we should be able to, and I'm just not seeing something obvious here. So forgive me if that's the case. Sometimes when you're solving these on screen, you don't see the wood for the trees. That has to be a 6, because it can't be a 2 or a 5 because of this. 6. Which is helpful there, because that forces this to be a 4 and this to be a 3. Yes, I think basically the puzzle is done now. We know we have to make these 2 add to 8. The only way that's going to do that legally is if these are 1, 7, 1, 7. This 7 here forces the 7 into the lower position, which gives us this 1 here. Oh no. This can't now be a 4. Oh, this can't be a 4, because look, there's a 4 up here. I should have seen that earlier. So this has to be 9, 8, 3, 7, like that. 3, 5, 5, 2. 4, 6 into these positions. This has to be the 6. There's something fairly cathartic about this stage of solving one of these. It's probably quite boring to watch, but when you've done all the thinking and it's just a case of not making a mistake now, which actually can be you know, one of the hardest things, because your brain sort of goes onto autopilot and you have to force it to concentrate a little bit. So 6, 7, 8 along here, 6, 8, and that's going to be it. So I hope this was useful. I think the logic down in this bottom left box was really really interesting today, and I hope you agree. I hope this has been useful. Thanks for watching.